In this problem, the missile at point A takes off from rest and rises vertically at B, where its fuel runs out in 8 seconds if the acceleration varies with time as shown, you see. So we have to find the missile height h and the speed vb. So, and also by initial controls, the missile is then suddenly pointed 45 degrees and allowed to travel in free flight. So we have to find a maximum height attained at point C and a range R to where it crashes at D. So through this statement, we observe that acceleration varies with time. And as the acceleration increases, time also increases. So you see, this curve shows that acceleration and time are directly proportional to each other. So acceleration is equal to 40 divided by 8 multiplied t. So acceleration is 5t. So to find our velocity, we have to integrate acceleration. So we have to integrate velocity from 0 to v and time from 0 to t. So we get velocity that is equal to 2.5 t square. And if we put a value of time that is 8 seconds, so we get a velocity at point B that is 160 meter per second. And to find the height at point B, so we have to integrate velocity. So we get distance. So we have to integrate distance from 0 to s and time from 0 to t. So we get distance x that is equal to 2.5 divided by 3 multiply t cube. And here x is basically the height at point B. So again, if we put a value of time that is 8 seconds, so we get the height of the missile at point B that is 427 meters. So now we have the velocity and the height of the missile at point B. So to find the height of the missile at point C, we have to first draw the vertical and horizontal components of the velocity. So in the vertical direction, we have 160 cos 45 degrees, so it becomes 113.14 meter per second. And in the horizontal direction, we have 160 sine 45 degrees. So it also becomes 113.14 meter per second. So you see, in this example, we use cos with vertical direction and sine in the horizontal direction because you see that this angle is with the y-axis. So now if we use a third equation of motion, so we can find the height of missile at point C. So here the final velocity is 0 because at point D it hits the ground, and this is the point where we can find its final velocity, so it is 0. And its initial velocity, we know that in the vertical direction it is 113.14, and here acceleration is due to gravity and the missile is acting vertically downward, so we have minus 9.81 meter per second square. And SC, that is also HC, and initial height is 426.67 meters, that is at point B. So through this, we can find the height at point C, that is 1079.1 meters, or you can also write it as 1.08 kilometers from the ground. So you see the only thing left is to find range. So again, we can use the first equation of motion. So here S is R, that is range, and initial distance is 0. So, and velocity here is 113.14. That is the initial velocity in the horizontal direction and multiplied t. So here you see we have to find the time that is take that when the rocket or this missile hits at point D. So we can again use the third equation of motion. You see, in projectile motions, the equation of motions play a very important role. So again, here the initial height is 426.67 meters, while the final height is 0, and initial velocity is the vertical direction is 113.14 meter per second, and we have time, and again the acceleration due to gravity, that is minus 9.81 meter per second square. So if we solve this equation for the positive root, so we get time that is 26.81 26.36 seconds. So when we put this value in the previous equation, so we get the range that is 2.98 kilometers.